So today, IoT, and I put the additional I for industrial IoT, plus and ICS are in some confusion in what is what, because companies that used to offer machine-to-machine solutions, which are pure industrial solution, just change the name to become IoT vendors. And of course, it's very sexy, but practically when we are referring to industrial implementation, we can see it in many sectors and aspects of our life. And in this presentation, I will focus on industrial control system challenges and security solutions, and of course case studies. And I will put the IoT just as a remark here and there, but those areas are really sound quite together all the time. So what are the risks? What is the challenges of security when we come to ICS and IoT? And I still leave the IoT in the picture in this area. So we are talking about vulnerability of the assets, PLCs, maybe even a light bulb that is today part of the smart technologies of smart home and smart office. Those are vulnerable assets and therefore are a risk for security. Lack of visibility. We don't really know what runs in a SCADA network, in industrial control network. We have to bring technology that first will give us the visibility of what is running over there before we can secure it, because if we don't know what it is, how can we secure that? And no inherent security. Just in the last year or two, we start see RTUs or PLCs that having encryption or some means of security integrated into the solution. In the last 40, 50 years of this industry, there was no security at all. It was not in the mind of the designer of those technologies. East and west, communication between one light bulb to another, one video camera to another asset in the organization, or from one PLC to another PLC. This communication is not seen, and definitely open opportunities of how one device can affect another one, and so on and so on. So I'm not going to go through all of them, but as you can see, there is a lot in common to those security challenges and risks for the worlds of the IoT and ICS. Some of them are more popular in one of those areas, but it's less important. So let's focus on ICS. So where ICS exists? Practically everywhere in our life. Every electricity, water, gas, any utility, any transportation network, any signaling system on those transportation lines. Of course, manufacturing. Some would be considered to be critical manufacturing factories, some are not critical. The definition of what is critical and what is not is just a government kind of definition based on regulation that is coming into the world. And just in the US, we can define the Ministry of the Homeland Security has defined 16 sectors as critical. In Germany, only 7 sectors are critical. But practically, it's less important to our discussion over here, because what all of those have in common, and the last one, which is building management, that I will focus on in one of the case studies at the end, are all of them subject to the use of industrial control systems as the main asset of technology to make them work. And that's why it put all of those, the vulnerabilities and the risk in those technologies, put all of those industries into a security risk. Let's see what the ICS cert in the US is showing and telling us are the most prevalent weaknesses of the ICS networks. I'll not go through all of them, but the first one, and the most important one, is boundary protection. So what they are saying out of their surveys and research is that the majority of the problems are coming from the fact that the OT is not segmented from the IT. So I'm using a new term over here, OT, operational technologies, that are representing the ICS networks are not segmented well from the IT. This means that any malware that exists in our IT can easily penetrate and access the OT, and this is a risk. Authentication, allocation of resources. This is related to educated manpower, how to maintain those networks. physical access, the fact that there are no strict policies. Who is allowed to access a production floor and who is not allowed? In many companies, those restrictions are not really there. So all of those are reasons for the weaknesses of ICS networks. And where do we see it in place? So out of the ICS CERT research, the most attacked sectors last year, 2016, are the critical manufacturing. Chemicals, food, and some others that are considered to be critical manufacturing. The second is the communication market that has nothing to do with ICS. That's why I'm not going to refer to it. But what is next? Energy, and then water. All the others are smaller. So look, our life are depending on energy and water and critical manufacturing, chemical factories and others. Those are the most attacked sectors. So this is where the risk is. Another survey by Statista is showing from their survey that 26% of the energy companies that they have interviewed last year reported on the fact that they have been attacked. So this is an important factor. So 1/4 of the companies that they have talked to admitted in the fact that they were attacked by cyber attack. I don't know what it means about the 75% that didn't admit. It does not really mean that they were not attacked. So this is important. And then manufacturing, 22% of the companies, infrastructure, 19%, and so on and so on. What I would like to show is that all of those highlighted sectors are using ICS networks. So the attacks are everywhere all the time. How the attacks are happening? Discom key, spear phishing attack. Somebody is sending an email with an attachment, and this attachment contains some malware that when the attachment is being opened, this malware finds its way eventually after searching around the network. He's looking for a PLC. He was designed and programmed to look for a PLC or an HMI. He was designed to cross the network as much as it can until it finds an ICS element. So spear phishing, endpoint security, removable media are all the same. Remote technicians. Every factory today gets remote maintenance by the vendor who supplied the manufacturing equipment. It means that if it's Siemens or GE or whoever it is, they have a remote access connection directly to the production line. I'm not saying that they are ignoring the needs of security, but I can tell you that in a meeting that I had with a light drinks company that have 12 production lines, each and every one gets support from another vendor. They have 12 VPN lines over ADSL or other connection to the production lines. None of those VPN is going through the firewalls of the organization. It goes directly to the production. The CISO of this company was almost crying that he is not allowed to touch those lines because the operation manager does not allow him to touch it. Why? Because it's his responsibility. So politics and other issues are opening a lot of space for hacking and for accessing those networks. And more issues. I'm not going to get into it. So understanding that the risk is there, the vulnerabilities exist, and the fact that we have to secure it is something that, to our understanding, is already a well-known understanding that the ICS networks are vulnerable and has to be secured in a dedicated way, and not only counting on the fact that one of the statements that we hear a lot, yes, my OT network is disconnected from the internet. There is no risk. That's not true, because if the manager takes his laptop home or to a coffee shop and connects over there just to do whatever he likes, and then he brings the same laptop the day after to the OT network to do some reporting, he's not realizing that he brings the malwares in. And this is something that, again, you hear from people that are really not aware of what they are doing. So, of course, we are here in a Checkpoint event, and Checkpoint has the solutions and the security solutions for the ICS environment. Let's go quite quickly about what the solutions are. So the idea is how to secure OT network. And OT network is industrial control system. Industrial control system consists on several technologies. The most popular one is SCADA, We can see DCS technology as well, and maybe some others, but let's focus on SCADA. So what we are saying that in order to secure OT network, we have to secure both OT and IT. And why? Because if we understand that one of the most popular attack vectors is something like spear phishing, it means that an email is being sent to the IT, and from the IT, the malware in the attachment, assuming that they don't have sandblast, will find its way to the OT. So what we are offering is to use the sandblast technology that we have in the IT and endpoint security in order to eliminate as much as possible any attack that comes from the IT to the OT network. So I'm not going to talk about sandblast here, but that's something that is supported by the ICS CERT report, by the popularity of those attacks, and so on. The second thing, which is completely supporting the first reason that the ICS CERT is finding as the result for weaknesses in the OT, is lack of boundary, they were calling it. I will call it segmentation. The need to have a clear segmentation between OT and IT is the first in line when you come to deal with OT. And this is, again, nothing to do with the SCADA. It's only correct architecture and the right design, how to secure the OT environment. And just then, let's deal with the traffic itself in the SCADA network. And what does that mean? One of the things in the first slide, we're talking about visibility. If we don't know what runs over there, how can we secure it? So the first thing that we have to do when we come to secure OT network, ICS network, is to provide technology that can provide us visibility. Because if we have visibility, then we can secure. So recently we improved quite a lot our visibility functionalities in the solution that we have. So for those of you who are familiar with that, maybe you will be surprised to see what I'm showing now. So visibility comes in many aspects. The first thing would be, let's identify what runs in the network in terms of protocols. And in the SCADA world, there are about 300 different protocols. This is an old industry with many vendors, many proprietary protocols. Some are old-fashioned based on serial connection. Some are IP-based. So first, in Checkpoint, we support only IP-based protocols. So this cuts out, 200 old protocols that we do not support, and we have no plan to support. But we do support more than 50 different protocols today. It means that we have the ability to provide visibility in a case that one of those 50 protocols running in the network, we will identify it automatically and we log it in our management. This is the visibility of the protocols, and not just the protocols, but the commands which are the sentences of the protocol. So we will see what exact command was sent from a SCADA system to a PLC or from one device to another device. I mentioned before east and west. One PLC can communicate with another PLC. We can see that, and we can log all of it in our management. The second level, and this is the new part in our solution, is asset information. Asset information means that in addition to the network monitoring of the protocols and the commands, we can tell you which vendor is providing a specific PLC, which model, which firmware, and by that, we can give the last and the most important part of the solution, we can give a network mapping. It means that we have the discovery capability of all the assets, the vendors, the names, the models, the firmware, and so on. And we can show a map of all the connections within this network. So if a specific PLC is communicating with an HMI or with a SCADA system, the map, as very high level showed over here, will show the connectivity between each and every one of the lines based on the real communication that happens over there. Now, if this is the visibility that we have, let's go to the next phase, and the next one is enforcement. So it means that now, after knowing what we have in the network, let's start play security, because until now, it was not really security, it was asset management and network monitoring. So when it comes to security, there are two aspects of that. The first one are the predefined policies. It means that if we learned and let the network run and we logged traffic for a week or two, we learned that in this network we have a variety of protocols, variety of commands, which are representing the normal behavior of the process of this manufacturing plant, or of this water system or electricity system, doesn't really matter what. After the learning, what we know is what normal, what runs there usually. And then we can set policies saying, okay, only those commands that we saw in the last 1 week or 2 weeks of learning are allowed, and therefore let's make sure that only those will be moving without any interruption in the network. And if we see a new command that was not in the learning phase, we can alert on that. It's not necessarily means that it's a cyber attack. It means that we didn't learn it. And then we just have to verify what is this new command, and if it's okay, and it happens occasionally, let's add it to the policy, and next time we will not alert on that. So this is a predefined concept. This concept can build manually policies, what is allowed, what is not allowed, when a command can be sent, and when at what time of day it cannot be sent. So definitions of time of day, patterns of behavior. If a command is being sent 10 times in 1 second, it doesn't make sense because this process does not send commands 10 times in a second. So maybe it's a fuzzing attack, maybe it's another attack. We can identify the pattern and alert on that, and so on and so on. So all of it is predefined based on what we have learned, and then we build the policies. The second option is machine learning mechanism that learns the behavior, learns the trends, learns the normal behavior of this environment, and then it can alert on any kind of anomaly that it can find. What can anomaly be? Somebody is changing the firmware of a PLC. Let's alert on that, because we had the learning phase before of the assets. We know what is the firmware, and so on. We can learn if somebody is connecting a new laptop to the network. If he's allowed or not, we don't know, but at least we will alert on that. So anomaly from the normal behavior after a period of learning phase, this is something that will automatically be alerted in the system. What it gives us? It gives us probably the only solution today in the market that can combine their both. And combine means that we can have predefined policies on specific command or on specific something, at the same time get the anomaly detection mechanism and the alerts based on any anomaly that is being detected. So the combination gives the best of both options in one system. And then, after having visibility and enforcement, we do have additional tools. We can do virtual patching using our IPS IDS blade. I'm not getting to the details. We can provide the 1200R as a ruggedized firewall to be used in harsh environment where it is needed. Just to make a note here, 1200R, this ruggedized firewall, is not a dedicated product for SCADA. It is a dedicated product to be used in harsh environment, but the software inside is standard checkpoint software, and everything that I mentioned about our enforcement and visibility can be used, can be implemented with any checkpoint appliance. You don't need any specific blade or any specific appliance. Using application control blade, using IPS blade that exists in every firewall can do the job. So you don't need a special product for that. And this is just in case that you need to deal with a harsh environment. And very important is management. Management means that in one system, we manage the firewalls, the segmentation, we manage the visibility, we manage the enforcement, everything done the same R80, and can manage all the ICS network as well as the segmentation and, of course, the IT network at the same time. So, few case studies in the last few minutes that I have. Let's start with a production environment. Again, a very high level. It should be modified on a case by case. But over here, what we are showing is that this is the production floor, and many, many PLCs are managing the production, and they are divided into departments. This is a typical factory. It has many departments, many different areas. One department, the equipment can come from GE, another department from Honeywell, another department from another vendor. Each and every one is being monitored remotely, separately, and therefore what we are offering is micro-segmentation. We are offering to use, in this example, the 1200R, use the firewalls per department, per vendor of the production equipment in order to completely separate between one and the other to prevent any malware that comes from here to here if exists. And all of them are providing the same visibility and the same enforcement mechanisms that I was talking in the last few slides. Those can be connected to a central device if it's a remote site over a VPN. If it's in the same place, it will be over the LAN, over the same network. And here are the control center, the SCADA system of the environment, and the checkpoint management, and so on. So this is a typical shop floor, a typical factory environment. Yes? SCADA Historian is the SCADA server where the data that comes from the sensors which are connected to the machines in the factory are sending all the data, temperature, pressure, voltage, whatever. It's being kept in SCADA Historian or PI. There is several. It's connected on an OPC connection in many kinds. So different names, but this is the database of all the SCADA data that is being collected from the shop floor by the sensors that run over there. This is part of a typical SCADA environment, nothing to do with checkpoint. Electricity environment. Electricity environment is being first represented by the fact that there are multiple sites. The sites are being called substations. So in a typical network, they have dozens or hundreds or many, many thousands of substations, small ones, big ones, depends on the network, on the scale. I can tell you that we work now with a company in Italy in this case that having 400,000 substations only in Italy. So those are representing the new trend of the electricity world, which is smart grid. And under smart grid, you have new monitoring devices along the electricity grid. You have smart meters. You have a lot of other systems like the ability to do smart city based on the smart grid, like, for instance, offering Wi-Fi services based on the same communication links that is being used to monitor the quality of the electricity on this network. So it means that in many, many cases, a lot of new equipment is being installed on the electricity grid, which was not there before. And this is a very sensitive kind of equipment. Those are relays that can change the path where the electricity is going. It can be smart meters that if somebody will change the values, it can reduce the cost of the electricity to the people and so on and so on. So in every site of that kind, depends on the size of it, depends of course on a case by case, we will offer a checkpoint appliance as a gateway, as a security that deals with the SCADA traffic. If it's a big substation, we will deal with the IT traffic and we'll perform segmentation between IT and OT as well per site and so on and so on. So this is applicable and already installed in thousands of sites around the world, mainly in the US where they started first because of the regulation over there which calls NERC-CIP, and they were the first to implement security in substation. A typical solution can be found in many other sectors like wind farms or water site or oil and gas. They are all represented in the same way. They have many, many remote sites. They have SCADA traffic there. They might have IT traffic. So the same as with the electricity and the substations, all of those sectors looks the same. And this is why the drawing represents all of those sectors in the same way. The last sector that I would like to focus on is something that recently became sensitive to security as well, the same as the manufacturing, as I think. And I'm talking about building management systems. The fact that a data center can be attacked through the water system by flooding the data center or by the temperature that can be raised to a level where it will damage the data in the data center, it means that it's easier to attack the building management systems and to cause a damage to the data center instead of trying to get into the data itself. And this means that all of those systems, energy management, air conditioning, lighting, elevators, and so on, All of them are SCADA-based technologies. So the fact that those can be attacked and they are vulnerable exactly as in a factory or an electricity grid means that it's a subject for security, subject for the same kind of solution: segmentation, SCADA monitoring, visibility, and so on. How does it look like? It looks like that. This is a building, elevator, air conditioning, water system, and others, connected in the building into a network. And the same visibility that we talked about with which are the assets and what is the communication, so on, is definitely applicable in this environment in the same way. And the firewall over here, which is the checkpoint firewall, will build a segmentation that one system will not affect the other system and will provide the same technology and the same solution as before, but here we can take it one step further. And the one step further is referring maybe to IoT in the enterprise way. And what do we mean? In a typical office, we have printers, we have smart TVs, we have Wi-Fi and other systems which are all connected to the LAN of the enterprise. It can be the light bulbs that I mentioned before. All of those are smart elements, IoT elements, communicating with maybe a cloud, communicating with somebody, and they are vulnerable and they are cause of a risk. So the fact that we can monitor the traffic that comes from those devices and provide a NAC solution, a visibility of which device it is, and we can do that, and we can understand the protocols that in some cases are called MQTT, in other cases called another protocol, but the same solution can be connected to the same firewall with the same monitoring capability, with the same enforcement capabilities. We will provide the segmentation here, and everything will be managed by the R80. So when you come to not just a data center, but a big building with many, many offices and a lot of technologies around, this is a solution. Just quietly between us, nobody's hearing us. Next week, we are going to install exactly this solution on the Checkpoint new building in Tel Aviv that we moved in, and it's a very smart building, a very new. And we found out that all of those systems are open. And now we are going to cover it exactly with this drawing. That's what it will be our pilot for this solution. So just consider that to you yourself and to your customers. One private case which represents one aspect of the solution. I'm here referring only to the elevators or to the air conditioning. As I mentioned before, those systems, besides the fact that they are part of the BMS, Building Management System, they are getting a service for maintenance from the vendor of the elevator. And this vendor has a control room that whenever there is some fault in one of the elevators, this PLC over there send a report, I am faulty, something. Now, that control room can do diagnostics from remote, but if it can do that, a hacker can do as well. And just imagine what a general manager of one of the elevator companies in some place told me. Just imagine that a hacker will take control of my lines over here and will drop an elevator from the 50th floor to the ground. He can do it because I can do it. I'm not going to do it because I give service, but he will do it just for the sake of the damage and for the noise that it will do. So he cannot take the risk. And that's why now we work with several elevator companies in order to secure this infrastructure of communication in a way that the communication will be reliable enough for the control center to diagnose and to maintain the elevators from remote. I'm giving it as an example for elevators or air condition. This can be a crane that is building outside, or a big tractors, or vending machines, or whatever you like. So any device, IoT, industrial IoT, whatever the name is, machine to machine, suffer from exactly the same problem. None of those are secured, none. Believe us. You believe yourself, I assume. And by that, I finished. Thank you very much. No, I have 1 second more. No, that's it, 0. My counter here says 0. Yeah, I know. That's why I stopped 5 seconds in advance. Yeah.
So here we go. They've turned the mic on. So while we switch speakers, So actually, you can go ahead and come up. So for those who are following along in the scavenger hunt, I believe the code is CPX checkmates.